Hello, you are most welcome, ladies and gentlemen, to Tuesday Night Anatomy with Daniel Okwan. Now, today's tutorial is going to be, continuation of the cardiovascular system that we've already begun. We want to actually look at fetal circulation or fetal blood flow, which you caption as intrauterine blood circulation. This is because we are looking at the blood circulation which is going to take place inside the fetus, in utero, inside the mother's womb. Now get to know that this circulation is going to be slightly or quite different from that we find in postnatal life or in adult life. So outside the uterus, the lungs are fully developed, and therefore we are going to find pulmonary circulation or systemic circulation. That one is quite functional. But inside the uterus, in utero life, what happens is that the lungs are not fully developed, and therefore we have this kind of peculiar, delicate, circulatory system in that of the fetus. Okay, and that is the reason. The reason is before you. The lungs are not fully developed. By ensuring that this fetal circulation is efficient, what happens is that the fetus, within its red blood cells, we have what we call hemoglobin, and this hemoglobin is called hemoglobin F, and that's the fetal hemoglobin. This fetal hemoglobin is very important because by way of competing with the adult hemoglobin, it has high affinity for oxygen, than that of the adult hemoglobin in the mother's blood. Again, apart from even having high affinity, what happens is that it has by way of unloading this oxygen to its cells or tissues, it's able to do that for the fetus, and therefore making this fetal circulation actually efficient because of having this kind of high affinity for oxygen, and this hemoglobin also having high unloading or offloading capacity. So without much ado, let's quickly go through this fetal circulation, but I begin with what we know already. Now we know that within the heart, we said that the heart is going to have two main chambers. This actually for the adults one is going to have two main sides. We are going to have the right side chambers, and we're going to have the left side chambers. Now I told you that within the right side chambers we are going to find only oxygen poor blood or deoxygenated blood, and then within the left chambers we are going to have only oxygen rich blood or oxygenated blood. We said that this complete circulation is ensured throughout life with the help of this septum, interatrial, and of course interventricular septa, ensuring that this complete circulation of blood, ensuring that oxygenated blood and deoxygenated blood do not get missed, is by this septa. Now get to know that blood, and for that matter deoxygenated blood, and that's why you can see that this one is showing this blue color, it's in blue color, and this is actually the inferior vena cava, and this is the superior vena cava. So deoxygenated blood or oxygen poor blood from the head regions, or those areas which are going to be found above the diaphragm, the regions above the diaphragm, the deoxygenated blood will get into the right atrium of the heart via what we call the superior vena cava, and then from the leg regions or regions which are below the diaphragm, the deoxygenated blood will get into what we call the right atrium of the heart via what we call the inferior vena cava. Inferior vena cava. And we said that this inferior vena into the right atrium actually relaxes to receive the blood, and then pumps it into what we call the next chamber, which we call it the right ventricle. I already told you that the superior chambers are the atria, or the posterior superior chambers are the atria, and of course the anterior inferior chambers are the ventricles. So it pumps that blood from the right atrium into the right ventricle via, of course, we said that is the tricuspid valve. So the right ventricle actually relaxes to receive the blood, and of course pumps it into what we call the pulmonary trunk. So within the pulmonary trunk too, you can see this pulmonary trunk, also showing blue color, telling us that the oxygen that is within is also oxygen poor. So the blood that is within it is actually oxygen poor, and it bifurcates, it divides into two to give us the left and of course the right pulmonary arteries. Now anytime we hear the word pulmonary, then it has to do with the lungs, taking this kind of deoxygenated blood to the lungs, and then the lungs will of course purified by way of oxygenating it, and then it will take a different route, yes, through actually what we call the pulmonary veins. So this is actually the left superior, left inferior pulmonary veins, and of course, the right superior and of course right inferior pulmonary veins. And the word pulmonary has to still do with the lungs. So these are the veins which are going to connect the lungs, of course, to what we call this time around to what we call the left atrium. So you can see that these veins are actually red in color, and therefore it tells us that yes, they are carrying oxygen-rich blood. So this left atrium relaxes to receive the blood, and then it is pumped into what we call the left ventricle, okay, and then via the bicuspid valve, and then it is pumped to what we call the aorta, ascending aorta, arch of aorta, and eventually to the descending aorta via what we call this aortic semilunar valve. This is what we call the circulation, which is actually going to take place inside the body. But what happens is that yes, we are able to divide it into two parts. We have what we call the pulmonary circulation, and we have the systemic circulation. Now, anytime you hear the word pulmonary, has to do with the lungs, and therefore with pulmonary circulation, it begins from where we have the right ventricle. So the right ventricle, yes, carrying deoxygenated blood, it pumps it, yes, into what we call the pulmonary trunk via what we call the the pulmonary semilunar valve, and then of course bifurcating into the left and right pulmonary, arteries, and then into the lungs for oxygenation. And then from the lungs, yes, this oxygen-rich blood which we now have will get into what we call the left atrium via what we call the pulmonary veins. And that is what we call pulmonary circulation. Now, for the systemic circulation, then it means that one we are going to begin from what we call the left ventricle. So from the left ventricle, the blood over there is actually oxygen rich. Yes, it is pumped into what we call the aorta, actually via what we call the aortic semilunar valve. Yes, of course, into then of course the aorta will distribute it to all parts of the body except the lungs. Now all these exceptions are with the lungs. All the exceptions are with the pulmonary. That is why in postnatal life, yes, we know that yes, arteries will carry oxygen-rich blood except the pulmonary artery, and then veins will carry oxygen-poor blood except the pulmonary vein. So all exceptions are to the lungs or to anything that has to do with pulmonary. So then, of course, it gets to all parts of the body, all body parts, and then of course it is returned into what we call the heart once again via these veins. Okay, the deoxygenated blood, okay, will get from the cells of the body after they've utilized oxygen and of course the nutrients into what we call the right atrium via the superior and inferior vena cava. So this is what I'm actually trying to say, that if it is pulmonary circulation, then it's going to actually move from this is the right ventricle into what we call the pulmonary trunk, and then bifurcating into the pulmonary arteries into the lungs for oxygenation, and then after oxygenation through what we call the pulmonary veins, it will get into what we call the left atrium, and that ends what we call pulmonary circulation or the pulmonary circuit. Now for the systemic circulation, we are going to begin from what we call the left ventricle. The left ventricle will of course pump that blood. It gets into what we call the pulmonary trunk, the aorta, and then the aorta distributed to all parts of the body except the lungs. It distributed to all those cells of the body, and then after those parts of the body have utilized it, yes, that oxygen poor blood will have to get into the right atrium of the heart once again, and then to go through what we call the inferior vena cava, and those ones from the head regions will come through what we call the superior vena cava, eventually into the right atrium of the heart. And this is what we find in the case of the adults. However, yes, I told you that because the lungs are not functionally capable of actually purifying by way of oxygenating, the blood, oxygen poor blood, then we have to have a special type of, circulation, and that's what we call fetal circulation. So we said that this fetal circulation is going to be efficient because the fetal hemoglobin is actually going to have high affinity for oxygen. So irrespective of the partial pressure of oxygen, the concentration of oxygen present, fetal hemoglobin will always, whenever you compete with adult hemoglobin, it will always win and therefore take up the oxygen. So for instance, if I take let's say the percentage saturation of hemoglobin, okay, of oxygen, both the fetal and that of the adult, at let's say 5, okay, kilopascals of oxygen, partial pressure of oxygen, then what will happen is that you can see that if I trace it this way, that of the adult reaches here, it will be somewhere here, okay. But if I take it to that of the fetus, it goes up. So it means that at any partial pressure level of oxygen, yes, the fetal hemoglobin, yes, has actually high binding or a high affinity for oxygen, than that of the adult hemoglobin. However, having taken the oxygen, now this oxygen will have to be unloaded or offloaded to the fetal cells or fetal tissue. And this fetal hemoglobin again has this kind of ease in releasing that oxygen, and that is what we mean by this fetal circulation, this fetal hemoglobin trying to help this kind of fetal circulation we are talking about. But remember, yes, postnatal life, most of the fetal hemoglobin will be replaced by, of course, adult hemoglobin, except in persistent situation where, of course, the fetal hemoglobin still persists, okay. And one thing is that, yes, even those individuals who present with sickle cell disease, especially sickle cell anemia, yes, what happens is that, yes, they are able to produce, they give them some drugs such as hydroxyurea, so that they can raise their fetal hemoglobin level to actually help them, because of course their adult form of hemoglobin is actually abnormal. Yes, so talking about this fetal hemoglobin, yes, fetal circulation, yes, around week 3, third week of intrauterine life, the embryo establishes this system. Now what we find is that we are going to have the placenta, okay. The fetus is going to bear this placenta. So this placenta will have the fetal part and, of course, the maternal part. But eventually, essentially, I'm talking about the placenta. Now this placenta is connected to, of course, the fetus via what we call the umbilical cord. This is the umbilical cord. Now within the umbilical cord, we have a single vein, a single light vein, and 2 arteries. So we have umbilical vein and then 2 umbilical arteries. Now, unlike post-fetal life, where veins will carry oxygen poor blood or deoxygenated blood, and of course arteries carrying oxygen-rich blood or oxygenated blood, for the fetus, for the umbilical vessels, is exactly opposite. So that, yes, the umbilical vein will rather carry oxygen-rich blood, okay, and then the umbilical arteries will carry oxygen poor blood. Now get to know that these kind of umbilical arteries are actually branches of what we call internal iliac artery. I will show you that one. So that is what I'm trying to say. So it means that, yes, from what we call the the coronary villus, okay, of the placenta, that's oxygen rich blood which actually was taken from what we call the maternal uterine vessels, okay, who actually reach, okay, the fetus via what we call umbilical vein. But remember, we've already said that this blood, fetal circulation, because the fetus is actually, yes, the lungs is not functioning enough, very well, then it means that we have to do everything to bypass the lungs, okay. But again, this kind of blood, if it gets also into the liver, what will happen is that it will go through what we call first pass metabolism, such that what will happen is that the bioavailability of the substances which are supposed to be inside this blood, yes, will be reduced. Again, of course, it may become deoxygenated as well, and therefore we want to also bypass this liver, although some of them will get to the liver, which I will show you, and we bypass the liver via what we call ductus venosus. Now remember, from the umbilical vessels, most of the blood will have to get into what we call the right atrium of the heart, bypassing the liver by way of going through what we call this ductus venosus, because we're talking about the umbilical vein, so venous, okay. So from umbilical vein, it has to go bypass this lungs by going through a venous system, and that's why from the umbilical vein we have to go through what we call ductus venosus. So look at how it is ductus, US for US, so ductus venosus. I'll show you post-fetal life, what will happen where it becomes, ligamentous. Okay, and when it becomes ligamentous, it becomes for so ligamentum venosum. I'll show you these ones. So it means that these are the shunt systems. They are shunts ensuring that that blood doesn't get to the liver. And we are not getting to the liver by actually, because we are coming from the umbilical vein, then ductus venosus is going to help us do that. Okay, although some will get to the liver, I'll come to that one. Again, there's another shunt system. Okay, so from the right atrium, that blood, if it gets into the right ventricle, it's going to be pumped into the pulmonary trunk, and then of course from the pulmonary trunk, it is getting to the lungs. The lungs are not functionally capable. We want to bypass that one, and therefore by bypassing it, although some may get to the lungs anyway, I'll show you that one. And by bypassing the lungs, yes, we go through what we call the foramen ovale, which is in the interatrial septum, that opening over there, which of course in postnatal life becomes fossa ovalis. So that we have to shunt that blood to what we call the left atrium, so that from the left atrium, it's going to what we call the left ventricle, and from the left ventricle it's pumped to the aorta to be distributed to all part of the body except the lungs. So that is what we have to know. Again, yes, some of the blood will actually get into the right ventricle from the right atrium. Okay, I'll actually show you that one. But although it is in the right atrium, it is going to be pumped into what we call the pulmonary trunk. But we are saying that this blood, yes, majority of it shouldn't get to the lungs, although some bit may get into the lungs, which will come eventually into the left atrium of the heart via what we call the pulmonary veins. What will happen is that majority should get into the aorta. So there's that connection between, of course, the pulmonary trunk and the aorta, actually the edge of aorta, and that's what we call ductus arteriosus. Now this time around, because we are looking at the arteries, okay, pulmonary trunk is an artery, aorta is an artery, so connecting them will be an artery. So that will be, ductus arteriosus, okay, and that one, so that the blood, majority of the blood will get to what we call the aorta, to actually get to be pumped to that of the lower limbs, actually, because lower limbs can actually survive with that of the that of the limbs can actually survive with oxygen poor blood, and then more importantly to get into, so this is the aorta, okay, this is the aorta, continuation of the aorta, this is the abdominal aorta, so that the terminal bifurcation of this aorta gives us what we call the common iliacs, which we divide into the external branch and the internal branch. I'm looking at the internal branch. So once it gets into the internal branch, taking, branching from this internal branch will be what we call the umbilical artery. So please get to know these systems. These are going to be very important bypass, channels to ensure that, the blood, okay, oxygen rich blood actually gets to the brain of the fetus. Actually, a lot of it gets to the brain, and of course some also get to what we call the fetal myocyte as well, cardiomyocyte as well. So just by way of trying to give a recap on this, yes, here we are. This is the placenta, which receives this oxygen rich blood from the uterine blood vessels of the mother, and it will get into this by what we call the chorionic venous system, and then eventually we want that blood to get into what we call the umbilical vein. Now you can see that this umbilical vein is somewhat reddish or pinkish in nature, so it means that it is carrying oxygen rich blood. Now that blood, yes, most of it, yes, will get into what we call the inferior vena cava via what we call a bypass channel. Okay, this is a shunt, one of the shunts. That is what we call ductus venosus, because I told you that umbilical vein. Okay, so ductus venosus. Now, in fact, there were two umbilical veins, but one gets obliterated long ago, so we don't even mention it. So what actually remains is actually the left umbilical vein, So from the ductus venosus, yes, that blood, yes, is shunted into what we call the right atrium of the heart. But bear in mind that, yes, you can see that not all the blood is bypasses the liver. Some actually get to the liver to actually provide some nourishment to it. Okay, but again, yes, this that portion, which is this umbilical vein, so this is still umbilical branch of the umbilical vein, which gets to the liver. Okay, it actually combines with, actually the left portal vein. The left portal vein. The portal vein is going to supply, nutrient-rich blood to the liver. Okay, this is the left hepatic portal vein. Okay, so that they join over here, okay, into the liver, and then this blood will actually, yes, gets out of the liver. Okay, this one will get out of the liver via what we call the hepatic veins. There are actually 3 hepatic veins, the right, left, and of course middle hepatic veins, so that eventually it also joins what we call the inferior, it drains into the inferior vena cava. Okay, still having some oxygen content in it because it doesn't spend much time here. Okay, or essentially it is less compared to the blood which is shunted, okay, from the umbilical vein into inferior vena cava via the ductus venosus. Okay, so it gets into what we call the right atrium of the heart. So within the right atrium of the heart, yes, it is bypassed. Okay, now normally we expect that it goes into what we call the right ventricle, but in fetal life, most of the blood, okay, in the interatrial septum, there's this foramen over there which is known as foramen ovale, so that it goes into the foramen ovale to get actually into what we call the left atrium, and the system. Once it gets into the left atrium, yeah, that blood will get into what we call the the left ventricle, and it is pumped into what we call the aorta. Okay, and then it supplies the head and neck areas, especially the brain, and of course it also supplies other parts of the body except the lungs. Okay, but what happens is that, yes, some bits of the blood over here in the right atrium will actually get into the right ventricle. Yes, it's not surprising. Again, the oxygen poor blood which has been used by the head regions, especially the brain area, as well as on the upper limbs, will actually get into what we call the the right ventricle, the right atrium, via what we call the superior vena cava. So that blood is actually oxygen poor. So that blood, together with that one which was left inside or which entered the right ventricle, they will all come into the right ventricle. So once in the right ventricle, yes, it is going to be pumped into what we call the pulmonary trunk, So here we are, this is the pulmonary trunk. So inside the pulmonary trunk, we know that it's supposed to branch into left and right pulmonary veins, pulmonary arteries, to actually get to the lungs. But we're seeing that the lungs are functionally incapable. Therefore, there's a connection, a bypass system, so that most of the blood in the pulmonary trunk will actually get into what we call the arch of aorta. And from the arch of aorta, most of the blood, yes, we say that is going to the lower limbs to supply that with the lower limbs. But these limbs can actually supply with less, oxygen-rich blood. But more importantly, from the descending part of the aorta, actually the abdominal aorta, in the postnatal life at the level of L4 vertebral level, it actually bifurcates to give us what we call the the right and left common iliacs, which would then divide into what we call external branch and of course the internal iliac branch. Now I'm interested in the internal iliac branch. It's the internal iliac branch which is actually carrying this oxygen poor blood from the aorta to what we call the two left and right umbilical arteries. This time around arteries, because aorta is actually the largest artery in the human body, so it branches left and right pulmonary arteries. So I told you that these pulmonary arteries, left and right umbilical arteries. So these umbilical arteries, yes, are going to carry what we call oxygen poor blood. Okay, so that's what we are actually going to see. So very important. This is actually the fetal circulation. Now get to know that, yes, some bit of the blood, yes, may not get into the arch of aorta via this ductus arteriosus, may go into the left and right branches of the pulmonary trunk and may reach the lungs. When they get to the lungs, because the lungs, there are cells over there, so they need to also survive, so they may receive that kind of blood and get some nourishment out of it. So from the pulmonary veins, okay, then it will get into what we call the left atrium of the heart, and of course in the left atrium of the heart, of course, it is formed into what we call the left ventricle, and then into the pulmonary trunk, so that yes, it will actually get into the arch of aorta, and then into the aorta actually, and then eventually it is taken to, of course, the branches of this internal iliac, being the umbilical arteries. So this is what we call fetal circulation. It's slightly different from what we find in the case of the adults, and that's what we are going to see. But bear in mind, yes, this placenta is able to do that. It's able to bring this oxygen rich blood, yes, because it's, or let me say that, yes, by way of its characteristics, yes, it's actually going to be permeable, okay, to actually water, glucose, some amino acids, some minerals, actually some electrolytes as well, may go through it together with the oxygen. So not only oxygen rich blood is going there, but actually nutrient rich blood as well, from the mother, okay, gets to that of the fetus, So that is an important thing that you are going to see. So by so doing, that's oxygen poor blood or deoxygenated blood, which is rich in waste as well, okay, will get into what we call this placenta, okay, and therefore this placenta becomes a very important filtration area, filtration site. When you look at some bits of embryology, we look at this kind of placenta, we look at it, a closer look at it, okay. So we've seen it, yes, one of them being, of course, ductus venosus, okay, is going to shunt this time around oxygenated blood from, of course, the umbilical vein, okay, to the inferior vena cava, so that we can bypass the liver. And by bypassing the liver, we are bypassing what we call first pass metabolism. Yes, apart from that, we've also seen that there's also going to be a foramen over here, okay, in the interatrial septum, and that's what we call foramen ovale. That foramen ovale is connecting the right and left atria, so that yes, oxygen rich blood from the right atrium will get into the left atrium, bypassing the right atrium, and of course therefore the pulmonary trunk, and for the lungs, okay. Then apart from that, we also have what we call the ductus arteriosus, so that most of the remaining blood in the right atrium, so right ventricle, which may get to the pulmonary trunk and then into the lungs, most of them will get into the arch of aorta to be taken down into what we call branches of the internal iliac, that's the umbilical arteries, and then back into the placenta. So these are important bypass channels, yes, which we have to know. So that is that. Yes, we've said it's all over again. Yes, we said that the lungs are non-functional, okay, so the blood is coming from actually the placenta, okay, to the heart, but this blood that is coming from the placenta is actually coming from the uterine vessels, which are actually from the mother. These shunts, yes, so from the placenta via what we call the umbilical vein, actually the left umbilical vein. Then of course we've seen that from that vein, because there's a vein, then ductus venosus, then foramen ovale, then this time around, because connecting the pulmonary trunk, where it's an artery, to of course the aorta, arch of aorta, which is also an artery, then the duct, which we call it ductus arteriosus, will be doing that for us. So the question is, yes, all these things now immediately post partum, post fetal life, once the mother is delivered of her baby, her newborn, then what happens is that there will be modifications, okay, there will be drastic modifications. And what are these modifications that we are going to see? I will show you these ones, but for now just get to know that yes, this ductus arteriosus now becomes what we call ligamentum arteriosum. I will show you actually which one will actually form first, but ductus, US for US, ductus arteriosus will become ligamentum arteriosum. So this one is actually going to be a fibrous area. I will show you. And then this foramen ovale, yes, once, because of the pressure difference which is maintained between, of course, the right atrium and the left ventricle, so the left atrium, then what will happen is that yes, this foramen ovale will fuse or will close to become what we call fossa ovalis. And then we also have this, ductus arteriosus. This ductus arteriosus will become ligamentum. Sorry, ductus venosus will become ligamentum venosum. Okay, so UM for UM, US for US. Then these umbilical veins, yes, actually the left umbilical vein will actually, obliterate and becomes what we call ligamentum teres hepatis. Ligamentum teres hepatis. These umbilical, arteries, yes, will actually, also obliterate to become what we call the medial umbilical ligament. Okay, forming part of the medial umbilical fossa in the deep side of, the anterolateral abdominal wall. Okay, so that's what we are going to see. So it means that we don't need the umbilical vein, we don't need the umbilical arteries. That is why they become obliterated. Okay, so let me actually show you these ones. Here now, this is the midline of the body. Now in the midline of the body, you will find, this one, which we call it, the median umbilical ligament. Okay, now I'm not talking about medial umbilical ligament. In the embryonic life, it was what we call the urachus. Okay, urachus. But I'm looking at just moving away from this median structure. You can see there's a structure which is exactly medial to this. Okay, very close. It's actually lateral to this median, but very close than this structure. Okay, and that's exactly what we find over here. This is the median umbilical ligament. Okay, and then we also have this one. So the one which is just lateral to this median umbilical ligament is actually medial umbilical ligament. And this medial umbilical ligament is what I'm talking about. Okay, this one becomes the lateral. Okay, lateral umbilical ligament. I'm looking at the medial umbilical ligament. This medial umbilical ligament, yes, was actually the umbilical arteries. So that's why you can see two of them. Okay, this one here and this one here. So left and right, of course, umbilical arteries, now becoming what we call the medial umbilical ligament. And these medial umbilical ligaments, yes, will form part of what we call the medial umbilical foot. So that is, one thing that we have to get. Again, yes, there's this ligament. I'll show you proper. There's this ligament which is also in the midline. You can see that. And this ligament, actually lies, along the free border or the free margin of what we call the falciform ligament, which, of course, if you look at the video that I've done on the liver, you get to know that falciform ligament is actually dividing, the liver into left and right lobes anteriorly. Okay, so the lower margin or the free margin actually of what we call the falciform ligament, you can see this round ligament over here. And because it is round, it is teres, and therefore we call ligamentum teres hepatis. Now remember that we saw that there was a single, which was actually the left umbilical vein, and this is the remnant of the left umbilical vein, and this is what we call ligamentum teres hepatis. And because it's round, we also call the round ligament of the liver. So this round ligament of the liver, yes, will connect, actually the liver to, of course, the umbilicus, as you cannot see over here. Okay, and you actually see what it does again. You actually see this one. Yes, so this is actually this ligamentum teres. So there's the right lobe of the liver, there's the left lobe of the liver, there's a falciform ligament at the lower free margin of this falciform ligament. We see this round ligament also coming out, and this is ligamentum teres hepatis, the round ligament of the liver. We said that in fetal life it was actually the left umbilical vein, and that's why it's a single structure over here, and that is what we call which used to be the left umbilical vein actually. Now you can see that I'll show you something. Now you get to know that together with another structure. I'll show you. Okay, I'll show you that one. Get to know that the liver is quite a heavy structure. That's why you can see a lot of ligaments around it. Talk about the coronary ligament, talk about the right and left triangular ligament, talk about the falciform ligament. Okay, several ligaments. So there we are. Again, there is another ligament. Okay, and this ligament is ligamentum venosum. Okay, ligamentum venosum. Now in fetal life it was actually the ductus venosus. Now post fetal life we don't call it ductus venosus, it has become, you know, fibrotic. It has become remnant of this ductus venosus, and therefore we call it ligamentum venosum. Ligamentum venosum. So this ligamentum venosum, let me tell you something about it. What happens is that, yes, together with, now look at this. This is the inferior vena cava. This inferior vena cava lies in the fossa. Okay, please visit the video I've done on the liver so that you get more understanding to this one. This is the fossa, sorry, the groove that, you know, this inferior vena cava lies, and this is actually the groove for what we call the, you know, ductus venosum, sorry, ligamentum venosum. So that is able to help us, you know, identify one of the accessory lobes which can be found in the posterior inferior aspect of, you know, the liver, and this is the caudate lobe. So once I know that, yes, inferior vena cava, the groove is here, I know that, yes, ligamentum venosum is here, its groove is here, then I know that this is the, you know, caudate lobe of the liver. Again, if I see this one, if you come to the inferior aspect of the posterior aspect, then what will happen is that, yes, you can see the fossa for this, you know, ligamentum teres hepatis, which used to be actually the left umbilical vein. Okay, but remember, you don't have right umbilical, it's just the left one. The right one just becomes obliterated long ago, and therefore we don't even mention it. Now here is the quadrate lobe. Quadrate lobe, four-sided in nature, quadrate lobe. This one is caudate because it looks like, you know, the rabbit tail. Now, once I know here is the fossa for the gallbladder lies in this fossa for gallbladder, and I know there is this groove for what we call the, this ligamentum teres hepatis, round ligament of the liver, then it can help me locate this, you know, quadrate lobe. So these are, you know, the things that, you know, you have to actually know. Okay, so these are very important remnants which will be left, you know, after, you know, postnatal life. Now we also find that there will be another ligament which I told you. Okay, sorry, there will be another duct, or there will be another shunt connecting, of course, the pulmonary trunk to, of course, the arch of aorta, and that's what we call the ductus arteriosus, shunting that blood from the pulmonary trunk so that it doesn't get to the lungs anyway, so that it gets to the arch of aorta. This, you know, shunt system, or this bypass system in postnatal life will become remnant, become fibrotic to connect these structures, and that's what we call ligamentum arteriosum. Okay, so these are very important, you know, bits that, you know, we have to bear in mind, you know, about, of course, you know, the fetal, you know, circulation. Remember that if the fossa ovale, foramen ovale doesn't get fused to become, you know, foramen ovale, or doesn't get closed, then it may lead to what we call the persistent, you know, foramen ovale condition. Okay, and, you know, that one will be, may, you know, give way for that kind of, you know, defect, you know, atrial septal, you know, defect. Okay, which may not be very good enough. So this is what I have for you for today. I hope you find it, you know, quite helpful in the study of, you know, the cardiovascular system, importantly regarding fetal circulation. So may God richly bless you, and let's wait for other videos that will be coming.